Good morning. It is my immense pleasure to present my research topic on finger knuckle print recognition using complex conjugate feature vector. I am doing my research under Dr. Uma Maheshwari, Department of Information Technology, PhD College of Technology. Outline of the presentation. Let us start with the introduction and literature review related papers, and finally the proposed methodology, conclusion and references. Introduction. Biometric are human-specific traits that are employed in person identification and access control. Various biometrics such as fingerprint, iris, face, voice, fingerprint, palm print, finger vein, DNA are used in recognition. Even though we have various biometric traits, the hand-based biometrics are concentrate the researchers more due to their ease of use and low cost. So normally in this hand-based biometric, a fingerprint is used in most of the applications. Here the issue is it can be nowadays it can easily spoofed and detecting is difficult and it is not clear. So here we have move over to the finger knuckle print. It is a skin pattern of the back surface of the hand. And the advantage of using this finger knuckle print is it is rich in texture, uniqueness, and also it is contactless and less expensive. The structure of the FKP is that the back surface of the finger, we have three phalangeal joints, metacarpophalangeal, proximal interphalangeal and distal interphalangeal. In that, this proximal inter can be called as a major knuckle and distal can be called as a minor knuckle. Here we have used this proximal interphalangeal for our research work. Next is the literature review. Some of the review papers related to the finger knuckle print is presented here. So this finger knuckle print is used for a personal authentication, and the first work is that a novel finger knuckle print recognition algorithm used random coefficients. Here they have used random coefficient technique for extracting the features. The next paper is an efficient biometric based personal authentication system using a finger knuckle print. Here they have used one-dimensional Gabor filter for feature extraction and Gabor filter bank for feature selection. And the next is that Ajay Kumar. In the next paper also the Ajay Kumar will have presented. In biometric authentication using finger back surface, they have used texture and hand geometric features for features are extracted, and these geometric features are used for classifying the individual. The next is that personal identification using finger knuckle orientation features. Here they have used a random transformation knuckle code to generate the orientation features, and this orientation features are used for the classification. Next is the proposed methodology. In the proposed methodology, we are going to see the FKP authentication. The main objective of our proposed methodology is here we have using complex conjugate feature vector based on the parallel fission. And this is a feature level fission. We have used a technique. For extracting the features, we have used PCA and LDA subspace algorithms such as personal component analysis and linear discriminant analysis. And after extracting the features, these features are fused using a parallel fusion strategy, and this fused feature vector is given to the KNN classifier for the classification. The work overview is that the image is acquired from the normal camera, and then the pre-processing is done to segment the major knuckle and to remove the noisy data. And after that, these image features are extracted using the subspace algorithms such as PCA and LDA, and these complex vectors are used using a parallel fusion strategy, and this is parallel fusion complex features are tested using the Engg method, PolyU and IIT dataset. This is the overall figure of the KPI authentication system. Finger knuckle image is given and the features are extracted using the PCA-LDA, and this parallel fusion feature level fusion is based on the complex number feature vector and is given for the classification accuracy. The first stage of the workflow is the pre-processing. In the pre-processing, we have converted the given image into a grayscale image, and the median filter is used to improve the intensity of the pixel, to reduce the noise and to preserve the edges. And after that, it is given to the next stage of feature extraction. Features are extracted using the PCA-LDA, and the PCA is that is a transformation of high dimensional space to a lower dimensional. The main aim of this PCA is to direct the maximum variance of the given data. Linear discriminant is a linear regression model used to reduce the dimensionality of the given image space. The purpose of this LDA is to project features in higher dimensional space onto a lower dimension to avoid the proofs of dimensionality, while simultaneously it also reduces the resources and dimensional cost. The main differ of the PCA from LDA is that it will maximize the interclass variability and minimize the intra-class variability, and also it is used to measure the values within and between the classes. The next is the main projector. Next slide is that a parallel fusion of PCA-LDA based on the complex feature vector. This principal component analysis is a dimensionality reduction algorithm, and it will ignore the class separability. To avoid the PCS issues and to improve the feature subspace separability, linear discriminant analysis can be used, which will improve the regression performance. The LDA on the continues to assume a common covariance matrix among the classes which violate the normality principle. To overcome some of the limitations of PCA and LDA, and also to maximize the strength of the performance, the PCA-LDA combination is used in the work, where the PCA algorithm used to reduce the dimensionality of larger features, and LDA is used to weight to increase the separability between the classes. The fusion is a pre-processing process included in feature combination. There are two types of fusion such as parallel and serial. The serial fusion concatenation of the features, resulting in a significant increase in the classification training time and detection time, which is not good for real-time applications. To solve these issues, the study proposes the parallel fusion of complex vector based on Euclidean distance classification, neural network, and KNN classifier. The datasets used over here is IIT Delhi dataset. Both are the finger knuckle images from IIT Delhi dataset and the PolyU dataset. The IIT scores 158 users with image resolution of 80 x 100 pixels, and the PolyU dataset which consists of 165 users with an image resolution of 160 x 80. And we have used the MATLAB for the coding. Finally, the result analysis. The results The primary goal of this experimental investigation is to determine the significance of single finger dorsal surface patterns in the biometric authentication process. The experimental study determined the efficiency of three proposed PCA-LDA complex conjugation based on three classifiers such as KNN, Euclidean, and neural network, which are implemented based on the two data sets, IIT and Praveen data set. We have conducted experimental analysis based on two sets. Experiment 1 is carried out by comparing the serial fusion of vector with the parallel fusion, and this experimental 2 is based on the parallel fusion with a number of classes. The proposed system uses this hybrid PCA-LDA complex conjugate feature to recognize the FKP images. The experiments were conducted to determine the best possible performance of the finger knuckle recognition and the performance of the FKP generated with an accuracy metric. And here we have tabulated the proposed with the PCA-LDA scores: 92% for KNN, 88% for Euclidean classifier, and 75 neural network for the IIT Delhi dataset, and 97 for KNN, 96 for Euclidean, and 87% for neural network for a PolyU dataset. And experimental 2 is based on different that it is continued over here, is that based on the Euclidean classifier for a number of classes. So for a 5 users, it has scored 100% accuracy for a PolyU dataset, and for IIT only for a 5 users it has scored of 100%, and for 30 classes, that each class contains 5 users, almost for 150 users, the IIT have scored 89% for a Euclidean classifier, and 96.67 for percentage for a PolyU database for the Euclidean classifier. So normally, and again for a KNN classifier also, it scored 92 for an IIT and 97 for a PolyU. Almost the PolyU database scored a better accuracy when compared with this IIT. And for neural network also the same case, it scored 87.6 for an 100 epochs for PolyU, and for the same epochs IIT scored 78% accuracy. The next is the comparison of our proposed methodology with other state-of-art approaches. The feature of FKP extracted using this hybrid PCLD with complex scored high performance when compared with the previous proposed methodologies. Zhang et al. 2009 with 76, and Xue et al. With 74, Zhang et al. With 84, and consequently in 2021 they have used relaxed local ternary pattern, and they have scored 96% of recognition accuracy. Here the PCLD with KNN achieves a classification accuracy of 97%, which is higher than that of 86 and 96 achieved by the neural network and Euclidean classifiers respectively. But almost the proposed with KNN have scored high accuracy among the other state-of-art methods. And finally, we have come to the conclusion of the research work. The finger knuckle biometrics uses a texture-based feature for improved results, but here we have used the subspace algorithms for extracting the features such as a PCA and LDA, and the combination of these PCA LDA features are done with the parallel fusion of feature vector, And we have conducted the experiment in two different data sets such as IIT and PolyU dataset, and comparatively the PolyU score achieves high percentage accuracy with the 97, 96 and 86, and correspondingly 97, 4